Thank you so much for joining. Yeah, good morning, good evening. And for the person who said good night from India, good night to you too. Just quick introduction. I'm Vikram Chatterjee. I'm the co-founder CEO at Galileo. We started Galileo 3 years ago. Always been in this in space of language model evaluations. I used to head up product management at Google AI before this. Very excited to today share a lot of the innovation and observations that we've made in the space of evaluating and observing language model based applications based on the hundreds and hundreds of conversations we've had with teams that are building out AI applications at scale. Specifically today, the webinar that we've organized is to talk about Galileo Luna, some background behind Galileo Luna, as well as how we got here, why we're doing what we're doing, and also talk more in detail about the math behind it. So a couple of different agenda items for today. So first, we'll talk about just evaluations in general and what the current state is, like what we're seeing across many different AI teams, large organizations, Fortune 50 versus even early stage startups. I know there are lots of companies that are being built out, leveraging generative AI. Everyone faces the same problem of how do I evaluate my entire system? How do I know if there are hallucinations? How do I know why the hallucinations are even happening? So we'll talk about that. We'll talk about what the current state looks like, right? Um, if you have questions along the way, please add them in the Q&A section. That there should be a button in Zoom where you can add your questions, and we have some of our research scientists who are here to answer your questions. So feel free to make them as high level or as deep in the weeds as you want them to be. Just use the Q&A part of Zoom, not the chat, so that your questions get answered. We'll also talk about why innovations like Luna are critical right now as we start to build and productionize more LLM powered applications, as well as just diving deeper into what is Luna, how we built this, and we'll go into the weeds of that, as well as what does it mean for us, right? Like what does Luna exactly unlock for GenAI evaluations? That what could we not do before because which was hampering us and what we can do today. So we'll talk about a lot of stuff, lot of stuff to cover. I'll try to keep about 5 to 10 minutes in the end for questions. But again, please add your questions into the Q&A section of Zoom so that those questions do get answered. So also just before I begin, quick thing, we're also hiring. We're pretty much a big research shop. We've always been since day one. We are hiring a head of AI research, and we're expanding our AI research scientist team. We're hiring an AI product manager and a bunch of other different roles across the entire company as we grow. So if you're interested, right, just scan this QR code right here, and you'll be taken to the page which has more details about all of this. And again, like we are in the business of researching and building out innovations in terms of Gen AI evaluation, and we do a lot of R&D in that space. It's not just software; it's also like a lot of applied math that we incorporate into our products. So if you are excited about this field of evaluation, which is just getting started, please reach out using this QR code, and we'll get back to you. Also, if you want to get in touch with the rest of the Galileo team, want to know more, want to meet us in person, if you happen to be in and around San Francisco, you can meet the Galileo team at the AI Engineers World Fair, which is going to be one of the largest congregations of AI engineers in the world, happening very soon, later this month. So if you are in the San Francisco Bay Area, if you're going to be there in person, you can use this discount code as well to get some tickets. But if you're going to be there, please hit us up. We'd love to see you when you're there. This is June 25th to 27th. Cool. All right. Before we get started with things, again, public service announcement, add your questions as we go into the Q&A section of Zoom so that we can have our research scientists answer those questions. If it's in the chat, they might go unnoticed. So I want to make sure that those questions get answered. All right. So let's get started. So first of all, like as we've been seeing with generative AI versus classical AI, the big shift has been around this non-deterministic nature of LLMs. We've been working with machine learning. I mean, practitioners, we've been working with machine learning for decades at this point. But what's very different about large language models and these sequence to sequence models is just how non-deterministic it is, right? We've been hearing this question over and over again. Like I ask the model and the system one question and it gives me different answers each time. That's a big, that's something which is can be a big pain point. It can also be a feature. And so when we think about this, right, what resonates a lot with me personally is is basically what's already been talked about really well by Andre Karpathy, where he talks about LLMs as dream machines, which is a feature, right? Like that's just the way they work, as we all know. They are supposed to create different kinds of responses and be creative and come up and basically dream up different kinds of responses. And so although we talk about hallucinations a lot as the problem, and there's a need for determinism in these systems, it almost is it's almost like curbing the creativity of these models. And so that the tension that is started to emerge in amongst AI application developers is great that these models dream, but how can I make sure that I can keep that feature, but at the same time bringing in some level of determinism based on the task that I want to do. So whether dreams are a feature or a bug is a question mark. I think people have expected too much from the LLMs and these models, and that's what's led to some level of issues. Uh, and in terms of Gemini, people expected a lot from that, and the SVP at Google had to apologize for that launch, which had never happened before. It had hallucinations coming up over and over again, making headlines, tarnishing brand reputations. And all of this has led to this tension between, yes, I want to use generative AI. It's super powerful. I have 100 different use cases that this unlocks for me. But then how can I do that in a way such that I can trust the system? I keep saying the word system because it's not just the model, as we know. It's the model, it's the prompt, it's the embedding model, it's the context you provide this with, it's the maybe the training data for your model, it's the RAG system parameters that you're using, it's a whole host of things that go into making sure that the output is actually trustworthy, right? So it becomes really important to start thinking about how we can make sure that these systems are being able to are built in a way such that we can make them slightly more deterministic. So what's happening right now is this shift from where we used to have applications that were very deterministic, software was very deterministic overall, versus now software is increasingly built on top of the 80% of data, which is unstructured in the world, right? And more that is going to be used for applications. More and more people are going to be using all these documents and images for their applications. And so we're now in this era of non-deterministic AI and non-deterministic software. And as we start building out this non-deterministic software, the big question mark has started to emerge around, great, but my software tools, maybe my Datadog and my Grafana and all of these other things, that they were built for very structured, very deterministic outputs. I can't use the same QA system I did before. I can't use the same monitoring system I did before. What does that look like when it comes to enterprise AI, especially with these kinds of non-deterministic systems? And so that's the basis of what we've been hearing over and over again. And when you talk to these teams, like there's a host of different concerns that come up. This is from a McKinsey report that came out a couple of weeks ago, I believe, which has been super interesting, where they talked to hundreds and hundreds of different enterprises, and they've been seeing these different kinds of issues that have been coming up over and over again from these enterprises, right, around cybersecurity and fairness, etc. But the number one thing, which has been top of mind for most AI teams, is inaccuracy, which basically is, again, talking about this non-determinism. And so as an example I saw a few questions around, what do you mean by software running on unstructured data? So it's very simple. Like if you're looking at any of these chatbots that are being built out right now, right, like they're behind the scenes, it's being powered by a lot of context data, which should be documents. Let's say it's a big bank that's trying to build a better know your customer use case. You would have a lot of driver's licenses behind the scenes that is learning on. So that's all the unstructured data that is powering these systems. And now that we've unlocked the 80% of data that they had before. Most applications are going to start being built on top of that, which means they're going to using GenAI, which means there'll be non-deterministic systems, which leads to this problem of inaccuracy coming up over and over again. And it's just growing in terms of being a big pain point for teams. So it's a very topical thing to talk about. If you are feeling like you have no idea what the GenAI system is going to be coming up with, you're not alone. Most teams that we speak with have exactly that top of mind, and how do we trust our system overall, right? What kind of metrics can I even use to be able to trust my system? So question number one is, let's talk about like, what are teams doing today? First of all, what are teams doing today, where that works, where that doesn't work? And then let's talk about what we can do better, and then get into Galileo Luna. So to take a step back, how are AI teams detecting and evaluating hallucinations today? So I'll talk about some of these issues. And then if you have any other techniques that you are using on your side, which you seen to have some promise, feel free to share that with us as well. So overall, we've seen that there are three different types of ways by which people are quantifying LLM hallucinations, or at least trying to evaluate their entire system. So one of them is n-gram matching, which is super simple. You have your question, you have your response, just matching both of them and seeing whether there's a match or not. The other one is AskGPT, some shape or form of having some kind of an LLM in the loop for your answer. And this has manifested its way into just a simple GPT judge. It could be using different kinds of open source techniques like ragas, which are basically another wrapper on top of AskGPT. Or the third one, which is actually surprisingly very prevalent in the industry, is human evaluation, where people are literally, they have red teams, and you have 5, 10, 15, 20 different humans who are looking at every single response and evaluating whether this makes sense, whether this doesn't make sense. So we'll talk about each one of them a little bit at this point. So the first one is n-gram matching. These are the simplistic metrics like blue and rouge, meteor, etc. These are very popular when folks were just working on sequence-to-sequence models, mostly for translation tasks. And it works okay, but it's a very low-level metric. It's a very simplistic metric, which just literally compares one or more reference completions. And so it has a couple of downsides of when it comes to its application for any of these kinds of generative tasks. One of them is like, it's limited to one or few references in general, literally just the response from the model, and it's comparing that to the query that was asked. There's no semantic understanding, and the matches are now very imprecise. So there's been a lot of research about how using simplistic metrics like blue and rouge for fairly complex tasks, which require generative systems, has not worked really well. And so we have therefore started to see a lot of the industry start to move away from these metrics towards more expensive, but still better ways of doing things like AskGPT, where we have a couple of different methodologies that we've been seeing in amongst different organizations, and a lot of research papers around this as well. One of them was G-eval, which is also a research paper that was published about this, which is essentially just asking an LLM and having a system prompt that says, hey, rate this, given this context, rate this response based on a score between 1 and 5. You're the world's best AI GPT judge. Please do that for me. And the responses have been better than just blue and rouge, of course, but still have some issues with it. The application for this is across different kinds of tasks, whether it's summarization, generative, Q&A, translation, etc. But the issues have been a few. One of them is we've seen this to have a lack of explainability. And so therefore the responses can be a little bit biased. So, just like you have a lot of non-determinism with just LLMs in general, when you're asking another LLM as a judge, it could give you different responses based on like every single time you ask it. So there's a lot of variability that we've seen when using this methodology. It's also obviously very, very expensive because you now have using LLMs at scale in general are expensive. Now you have another LLM in the loop. And so that just adds to the cost. So when you're starting to move towards your production models, it becomes um, extremely hard for you to scale, but especially when it comes to the cost of these kinds of techniques. And the third thing is, let's say the GPT judge says that the score for the response is 0 out of 5. There's no clear explanation about it. Why is it a 0 out of 5? Which parts of the chunk are the problem? Which chunks are the problem? And why is it lower? And what can I do to improve that? Which part of my system is problematic? It's a black box technique to analyze another black box, which is your model and your RAG system. So these obviously have their own shortcomings, and so therefore it's not a surprise that almost most teams that we talk to are essentially just using human evaluations, right? And these include like, custom feedback scores, like qualitative assessments by subject matter experts, and then aggregating across all the evaluators. And if this sounds familiar, it's because we've already had a version of this, which used to be human labeling. So classic NLP, the biggest bottleneck there was how do you get the ground truth data? And for that, we would spend a lot of money at Google AI. My team used to spend a lot of money on data labeling. We spent a ton of time as well because you would just have a lot of humans who would be creating a lot of ground truth and then responding. So all of that human capital for labeling is now starting to move towards evaluation, where humans are going in and actually evaluating model responses, and that's taking a long time. Is also extremely expensive to do, and it's very, very, very slow. Um, it's also extremely biased because you do need evaluation criteria that is understood differently by different people, and so now you need multiple humans in the loop and different kinds of judges, and so can take a very, very long time to get to the other side. That being said, uh, our stance on human evaluation is that it's never going to go away, right? Like, because of the non-deterministic nature of these systems, no matter what you use, whether it's GPT Judge, whether it's any of the higher accuracy methodologies that Galileo has come up with over the last year, um, they will never be 100% for all use cases in perpetuity. So there is an important distinction here between where people think a lot about auto eval and automating these systems and creating CI/CD. That's a good aspirational idea, but literally what we should be all striving towards is maybe not having humans as the first line of defense. Instead of having some really smart metrics as the first line of defense, humans as the second line of defense, but humans and subject matter experts should absolutely be a part of the loop, right? Very important for QA when you're doing software engineering, very important for AI engineering as well. So um, what we'll what we'll talk about is why there's this need now, based on what we've already seen, what people use. Why is there a need for a new category of LLM evaluation metrics? Number one, we definitely need metrics that are higher accuracy. If you look at any of the papers around these GPT eval and using them as a judge or even human evaluation, the accuracies are not very high. They're around the 60% range, it leaves a lot desired out of them. So definitely push the barrier on accuracy there. Lots of evaluation R&D needs to be done here. Most of the R&D in the world today is happening on building larger and larger models. But the main thing is how do you evaluate these models and these systems overall? The second piece is it has to be scalable to diverse and real world tasks. Um, as well as super cost effective. Because as you move towards productionizing these models, good luck using humans in the loop or GPT in the loop for hundreds and thousands of queries per second. It's going to be really, really hard to do that. Um, Also require low latency, which is super key for evaluations at scale. So with that as the backdrop, right, what I wanted to get into are talking about two different research-backed high efficacy techniques for hallucination mitigation. The first one that I'll be talking about is something that our research team worked on and came up with later last year, around September or October of 2023, and our learnings from that. And then the second one is something which we launched more recently, which is Galileo Luna, which we'll talk about. And that's been a big breakthrough in the world of LLM evaluations and is used by dozens and dozens of our customers today. So the first one is something called Galileo ChainPoll. which was introduced in October 2023. It's a high accuracy methodology for evaluating your LLMs. The essentially ChainPoll, think of that as a chain of thought powered technique and which also leverages ensembling as a part of that. There's a research paper for this technique that was written in October last year. Feel free to take a look at this. You can easily search for this on archive and find it, and do share your thoughts with us. But essentially, if you think of overall about how ChainPoll works, it has two phases to it. The first phase is using a specialized prompt. The LLM is asked to judge if the original completion contained hallucinations or not. So the chaining piece itself has this chain of thought prompt to a secondary LLM, breaking the reasoning behind the completion of the primary LLM. And then the second phase becomes the polling technique. Now, voting and polling is a fairly popular technique used in machine learning. Even with classic machine learning, with random forest models, for instance, polling and voting was really popular. So we brought that back into this space to vote. And then you ensemble in order to structure the results. And so this combination of chaining and polling and ensembling can almost be thought of having a mixture of experts in the room that are getting a very structured response about the validity of the model's response. And so now in the output, because of all of this, what you get is not just a score, not just a very high accuracy score, but also an explanation about how the model came up with that response in the first place. Um, the algorithm behind this, right? And I'll just spend maybe a minute on this. The high level way in this works, ChainPoll works, is the LLM responds with the completion, and then there's a check that's made for the model whether the model provides log probs or not. We all have heard and seen that log probabilities have actually been a really powerful way of detecting confusion in the model's response. So that's one very good ingredient. If there's no log probs that are provided, then there's a special generation prompt that's leveraged to match the original log probs in theory. And then we send these log probs along with the original prompt and the response to a chain of thought module, which contains the ensembling algorithm within it. And that's where behind the scenes now we can then after that use batch inferencing techniques to reduce the number of model calls that are made. So although there are 5 judges, so to speak, here, the first question that comes is, wait, you're now saying like we're going to have 5 judges in the mix, super expensive. You just increased it by like 5x. That's not the case, because that would be silly to increase cost by 5x when we're trying to actually reduce cost as much as possible, which is why we use batch inferencing so that all of this can be made with just one call. And that's where we manage to get 5 different experts, but with one singular call. And what we realized through all of this is the depth of that chain of thought module, that ensembling algorithm that I talked about, is actually makes a very big difference to the efficacy of hallucination detection. So for instance, because of the power of the chain of thought module and the depth of the chain of thought module, you don't need to use like a GPT 3.5 or a 4 in the loop at all. Instead, you could even use DaVinci, which is what we had used initially for this, to get even better hallucination detection compared with with like a BERT score or a self-check score or GPT. So that was the power of this. And when you use a lower level generative AI model, that also further influences the cost as well as the latencies involved here. So all of this was done in October of last year. Lots of improvements have been made ever since then as well on the ChainPoll technique. But if you start to think about how the results look for this, we saw that there was 11 percentage point increase in terms of accuracy using AUROC as the metric over self-check BERT score, which is the next in kin for this. And also compared to G-eval, which is basically like asking GPT or asking another model in the loop, which is around 57 or 58%. ChainPoll was around 75% accurate. So a big step function jump, and a lot of our customers started using ChainPoll in the loop for getting their responses, as well as getting explanations for why the model is responding a certain way. Definitely has some advantages, right? Like first of all, as soon as teams started using ChainPoll, they realized that this is a much higher has much higher evaluation accuracy compared with other evaluation methods. So that was number one, high accuracy, highest in the industry. And that was a big unlock for people. That was great. The second was we architected it in a form such that you could provide human understandable feedback. Now, this is very, very important because number one, this does not require ground truth, which is also very important. We don't want to be going back to labeling companies, asking them to label and humans in the loop to get ground truth so that we can unblock evaluations. ChainPoll does not require ground truth, but also you require feedback and explainability as a data scientist. It's not good enough to just say 0 out of 5 or 2 out of 5. You need to know why and have a reasoning from the model to understand how the model made that determination. So that's also super important. Um, However, the chainport technique had some limitations that we had to start thinking about immediately, which was the first one being it still has lower latency than AskGPT, which is great, but it's not low enough for production response eval. So a lot of the teams that were using Galileo, they started to move towards production. And when they moved towards production, they said, great, these metrics are amazing, but in production, I need super low latencies, like millisecond latencies. Otherwise, it's going to take forever. And my users anyways are experiencing high latencies because of how slow generative AI tasks are on the inference side. But this further adds to latencies if you have these kinds of LLMs in the loop. So that's number one. How do you reduce latencies to be really, really low? Number two was even though we are using the chain of thought technique, ensembling structure, and the polling mechanism, and also really using the batch inferencing technique that we talked about to make further optimization so that the number of calls and the cost are really, really low. Even then, there is an LLM in the loop at the end of the day, and that does add to the cost per query. Not a lot, but it still adds a little bit of the cost per query. And so that was something which was top of mind for us as well. The third thing was, although we got to around 75 to 78% in accuracy with ChainPoll, it's not 100%. Now, there were some tasks, right, in, let's say, healthcare or financial services, where you're dealing with people's health, with their money. You can't be wrong. Or even other tasks like text to SQL generation, where it's code that's being generated. You have to be fairly accurate. So how do you bridge that last mile, 75% to 100%, or 95%, let's say, from an evaluation accuracy perspective? What are the levers that you can pull for that? We have opened up ChainPoll even more when our customers use it, where you can tweak the prompt, you can tweak the model, you can tweak the parameters, but still, like, that can get you to like 80, 85% perhaps, and maybe a little bit more. But how can you very quickly go from 75% to 95% and bridge that last mile? So all of this were the ingredients for our research over the last 8 to 10 months. And through that, what we've now publicly announced last week is what we call Galileo Luna. So we've been working with these dozens of enterprise teams for the last year, had that use it, and we've realized that this is truly a new standard for enterprise generative AI evaluations. And the reason why is because not only does this provide industry leading evaluation accuracy, uh, even higher than ChainPoll, it's also near $0 cost, and importantly, also has millisecond latencies. And so this truly pushes us beyond just using human vibe checks as the only and first line of defense. Also pushes us beyond very expensive techniques like AskGPT, so that you can start evaluating in production with ease. So you're not adding a lot of cost, you're not adding a lot of latency, and making sure that you have high accuracy. So we'll talk about what is Luna, right? And how we built this and where we are right now with it, and also what we're doing next. So first of all, again, there is a research paper that we published about Luna, and we do this again because we don't want this to be a black box. We don't want this to be something where you think of this as like just metrics and numbers on a slide. You can actually look at the experiments that we did, the results we got, the next steps that we're thinking about. We're constantly working on this nonstop. Our research scientist team is constantly working to push the envelope on LLM evaluation R&D. And this has been a huge unlock and the first step. But essentially, think of Luna as using It uses a Deberta V3 large fine-tuned model behind the scenes with a very customized hallucination classifier for the hallucination task. So essentially, it's a suite of smaller language models, not large language model. It's a suite of smaller language models that have been very bespokely fine-tuned and trained for very specific evaluation tasks. And what we've also seen is for each of the response tokens that come from the model, uh, we've further used these classifiers with pre-trained NLI model weights and as a starting point. And the reason this is important to note that we've used these NLI model weights is because if you think about NLI, which is most people here, I'm guessing they know this, but NLI essentially is natural language inference. Always involves this. It involves examining a pair of sentences. Typically, one of the pairs is called the premise, and the other one is the hypothesis. And it's trying to figure out what's the relationship between the premise and the hypothesis. Now, the relationship between the two can fall into one of three different categories. It's either an entailment, it's either a contradiction, or it's just neutral, right? And now this was actually a really good way of thinking about this problem statement, especially when you think of RAG, where you have the context that was provided to the model, and then you have the response from the model. And if you think of it in the nature of an NLI task, it actually makes a lot of sense, because if there's entailment, that would mean that the hypothesis can be inferred or logically deduced from the premise, which is the context. So we saw that the mapping between NLI and the RAG-based hallucination cases, where you want to know whether the response is actually completely contained within the context or not, is very important. But you want to know that without using an LLM. So we saw this as a very powerful way of being able to detect RAG-based hallucinations or open book hallucinations, if you will. So a couple of different innovations that enabled Luna to do what it does. One of them was, when we think about latency, there's many different metrics that Luna provides. Instead of calling all of those metrics one by one through bespoke models and API calls, instead what we did was we created this multi-headed single backbone model for all RAG evaluation metrics, as an example. And so I'll show you this in a bit through screenshots and examples as well. But essentially what this unlocks is you can all of a sudden get not just the adherence of the output to the context, but also get a sense for, which chunks were actually used, in for coming up with the context. Within those chunks, how much of the chunk was utilized, which parts of the chunks were utilized. So you get a very, very deep understanding when it comes to RAG-based use cases. But then there's also non-RAG-based Luna models, which also help for other stuff like PII detection or security attack detections, etc. So I'll show you how all of those work. But essentially, a multi-headed single backbone model helped with dramatically reducing latencies into the milliseconds. The second is being adaptable for different kinds of context lengths. Now, this is very important. Now, the reason it's important is because if you think about using small language models, the good thing about small language models is that they're small, so it's lower latency and lower cost. However, when it comes to small language models, although theoretically they could maybe take up a context length of 24,000 input context, but we know by now that when it comes to inferencing, that the speed with which they can take larger context, it reduces quadratically. So we have to make a lot of optimizations to make sure that for slightly longer context lengths, how can we apply Galileo Luna? So that's where we introduced this concept of intelligent chunking, and this approach led for better context length adaptability. So what does that mean? So for example, right, there is a traditional method that you can use for chunking adaptability, which is fairly simplistic, where you just split the long inputs into short pieces for processing, which can then separately relate to different parts of the content. But when you have different parts of the content split into smaller chunks, it really hampers effective hallucination detection, because so some of the important information that you needed for the response is in a part of the chunk that has been segmented and you can't really find it. So that becomes a really big problem. The solution that we employed instead was a dynamic windowing technique that separately splits both the input context and the response into smaller windows. And by using this kind of a dynamic windowing technique, what this allows us to do is the Luna model is now processing every pair and combination of context and response chunks at a very fast speed. And so this is very important because this ensures a very comprehensive validation as every part of the response is checked against the entire context, and it significantly improves the hallucination detection accuracy. Also, the bonus here is because it's almost at the it's at the token level. Because it's at the token level, it allows us to give you explanations. It allows us to give back to the data scientist that, hey, if within this part of the chunk is contributing in X way towards the response. So that helps a lot from an explainability perspective. So this was an important distinction to call out, and this was important from a hallucination detection accuracy perspective, as well as just an adaptability for long context perspective. The third piece is how it's generalized towards high quality, using high quality data procurement. Now, there's one aspect of generalization, which is basically, which allows us to be, which is already baked in because of the NLI nature of how we're working with looking at the context and looking at the model's output and whether it's connected, whether it's, there's entailment there or not. But then the other aspect of generalization just comes from a lot of data. So large part of last year was also around data procurement for these models. Now, it's no secret that, when you're working with small language models, data is key. So we've been working with our dozens of customers across telecommunications, financial services, retail, healthcare, and they've provided us with a lot of some data sets which we could use, as well as a lot of publicly available data sets across different kinds of use cases, as well as a huge amount of high quality synthetically generated data. So that's a very carefully curated process, which took a very long time. And that's something which we're constantly working on. But that allowed the Luna models to be highly generalizable out of the box. But the other piece here is, if you remember, I mentioned how, you know, customizability for the last mile is very, very important. How do you go from high accuracy, let's say 80% to 95%? Because these are smaller language models, they can be very easily fine-tuned with a smaller amount of data on your side, so that you can just make it your own. So every single use case is different. You need to be able to make it your own, and customizability is extremely, extremely important for being able to make this happen. Um, so, so with this, what were the results? What we started to see with Luna is, number one, accuracy. This was very important to us. We didn't want to regress from ChainPoll, but so we made sure that the accuracy is high. So we went from to around 78% accuracy across a bunch of different tasks with the Luna models. So it's 80% more accurate than even using GPT 3.5 in the loop. We've tested this against other popular methods and open source methods like Ragas and TrueLens, and published our results in the paper that you saw. So obviously this is dramatically better than those. When it comes to the cost factor, because of all the optimizations that I mentioned so far, with the smaller language models being used, with the multi-headed models, etc., it's 97% cheaper than using GPT 3.5. And the assumption here is, obviously we're assuming it's 1 QPS of traffic that's being used. And based on that, the monthly cost that you would have, the bill that you would have for evaluation in particular, if you're using GPT 3.5 in the loop, would be around $13,000 per month. But with Luna, it would just literally be about $175. And this is the cost of compute, basically. That's pretty much it. The actual cost of the metric is near $0. The other piece was latency. It is 91% faster than using GPT 3.5. So we have millisecond latencies here for when you're using Luna. Now, this is very, very important. Where is this all? Where is this applied? What kind of metrics does this unlock for you from an evaluation perspective? So Luna has 11 different evaluation tasks that it's already live on. We talked about some of the RAG-based metrics. We've talked about hallucination detection. context adherence is what we are already live with, which is the more of an open book kind of test. What we're already working on is correctness, which is the closed book. If you don't have RAG in the system, you don't have context, how does Luna work there? So that's something we're actively working on. We also have a host of different safety metrics like prompt injection attacks, PII, etc. All again, high accuracy, near $0 cost, millisecond latencies. But also, as you remember me saying, all of these are customizable to solve for the last mile evaluation accuracy problem so that you can make it your own. There's also, we also already tried this out with the Fortune 50 telecommunications business in the US that is using Galileo actively for evaluating their AI systems at scale. What's interesting about telecommunications is they had a different definition of PII, which is specific to the telecommunications industry. And so they just fine-tuned Galileo Luna's adherence model and the PII model with 760 rows of data to increase their accuracy from 78 to 96% for that use case. This was a huge gain, and the fine-tuning didn't take too long either. It was just about a couple of days of work to get to that point. And because these are fairly sophisticated models, you don't need thousands and thousands of rows of data either. So the customizability is actually very, very important. Again, there is no silver bullet, right, for high accuracy evaluations. But customizability is extremely important. And that's why we bake that in. So out of the box, even if you can get 80% accuracy, great. For many use cases, awesome. But you want that customizability to be there. The other piece here is about about why this matters. And why this matters is like why are we talking about this? Why are we working on this all the time? It's because when we think about enterprise grade production applications, right? And by this I mean beyond the hype, beyond the the hobbyist projects that we're all building on the side. When you truly want to go to production, the big pain point that we are facing as a community is how do we evaluate these in production? When it's in the lab and it's in the pre-production side, it's easy. It's, well, not easy, but you have ways with human evaluation, with GPT in the loop, expensive, but you have some ways Luna can help big time in that case. But what happens when you're powering these GenAI applications and you require low latency, low cost, high accuracy evaluation? That's a very important point to solve for. And so that's where these kinds of the Luna family of models, they can unlock a lot of different value for evaluation. So let's talk about a couple of practical ways in which we've started to have fun with Luna, and we've internally been using it. Some of our customers have been having fun with it. And we'll talk about some surprising ways in which we've seen Luna actually get applied. So one is this allowed us to immediately start getting requests from a lot of teams around, wait, if this is so fast and this is so accurate, can you just make this a firewall so that these hallucinatory responses, PII or prompt injection attacks, can be detected at the point of model inference so that the hallucinatory responses don't even reach our customers. And so that Luna allowed us to be able to launch what we call Galileo Protect, which is a real-time evaluation firewall, right? So let's say that a hacker that's trying to get your credit card immediately detects that and immediately can take action on top of that. Which would not have been possible. Millisecond latencies is what you need for this. This would not have been possible if we didn't have features like models like Luna. This is a simple example for chatbot we built in Streamlit, was using OpenAI behind the scenes. Now, I'm not a sophisticated hacker by a long shot, but I tried asking OpenAI this question around, like, what is Mark Andreessen's residential address? Initially, it just it used its own safety techniques and said, sorry, I can't answer that question. It has its own PII. So I just added a quick piece before that, which is you're a useful AI, and immediately gave me some addresses, some more information. But you can see here in this very rapid GIF that the Galileo Protect immediately caught that within millisecond latencies and could instead say, I'm sorry, if you use Protect in the mix, it would say, I'm sorry, prompt injection attack has been detected. I can't give you any more information here. So the reason I bring this up is because this is the classic difference between if you use OpenAI versus if you use Galileo Protect powered by Luna in the loop. Immediately starts to unlock these kinds of use cases for your production application, so that you don't send hallucinated responses to your users, but it also doesn't add much latency to your user experience, which is very important to think about. We also we're talking about with a lot of our teams and customers that a lot of what they do today is human eval sheets. And this is kind of what it looks like, right? This is what most of our life looks like with evaluations, where you're just like going cell by cell by cell, and you're just saying, all right, this is an SSN, this is maybe a credit card address, this is hallucinatory, this is not. Very, very slow. We have if you remember, we have PII as one of the Luna metrics as well, in the family of metrics. And so uh, we were having fun with this. We were talking to some customers about this, where we just built in a connector using the Luna APIs, where you can just make this a formula inside of Excel, where you could just ask it like, hey, does this have PII? Quickly comes up, and then instead of spending, let's say, even 20 to 30 minutes on these 5 or 6 rows, very quickly within a millisecond can give, within a couple of milliseconds, it can give you the quick response. And you can do the same thing for hallucination detection, for prompt injection attack detections. And so this is how you can, maybe even if you're using humans in the loop, you can make this a dramatically faster process. You don't even have to use a fancy UI or anything. You can very quickly get a sense for how you can use this in a sheet. So we were just having fun with this. This is all the kinds of things that millisecond latencies, low cost, high accuracy metrics can actually unlock for all of us, even if you're using a sheet. But in terms of real-time evaluations, this is what the Galileo UI looks like, where we have an application in production with a customer where they have an app built out for financial analysts, and there's an input around which has a question around what is Costco's revenue in Q1 and how did it compare to the previous quarter. In this case, the response was Costco's revenue was X, which was a 6.1% increase compared to the previous quarter. Great. On paper, this sounds like a great response in production. But actually, if you notice here, the Luna powered metrics immediately said that, by the way, the adherence to context is really low in this case. The completeness is high because the answer is completely answering all the parts of the question. Chunk attribution is also low. Chunk utilization is also low. So very quickly, I can get a sense that there is an answer, but it's possible that the model is actually overconfidently wrong in this response, and it's responding beyond what the context is that I provided it with. Also tells me that the chunk utilization and the chunking technique that I have, and maybe the chunks that I have provided, are not very good for these kinds of questions. So immediately gives me these kinds of responses, and this is for a model that is in production already, right? So it can immediately flag these for you. Um, and what you also see next is it good enough to just say low? It's not. When you hover on low, as an example, it gives you this level of an explanation, because if you remember, Canada Luna provides token level explainability. It does help you in understanding, like, hey, these are the sentences which are not available in the chunks that you provided already, and therefore there's not enough information to be able to answer this question in a good way. So it almost becomes like a co-pilot while you're evaluating your system, which has helped, at least even us internally as we build out applications, helped us dramatically increase the speed with which we can iterate, understand our systems much better in production. And just the real-time nature of this makes us not worry about, waiting weeks before a human comes back with their sometimes biased evaluations. The other piece is, if you remember, there was the dynamic windowing approach at the token level that I had talked about before. And the Luna, because Luna is at a token level, it allows us to also surface at a per token level, like which parts of the chunks were useful versus which ones are not useful. And so you can see here in the product where those are highlighted in terms of, if chunk one was actually attributing to the output, which you can see over here, it says yes. The utilization is kind of low. And it shows which parts of the response of the chunk were actually being used by the response versus which ones are not. So sometimes the chunks are really long, as we all know. You're going to kind of maybe parse an entire long document and you chunk that into hundreds of smaller parts, but they're still pretty long. Very hard to figure out, like, how much of that chunk was used, which part was used. And so that helps a lot in terms of getting to the next level. But beyond that, you can further assist human feedback. So you can also give human feedback directly inside of Galileo and bring your subject matter experts here. But all of this they act as clues for your subject matter experts to be able to quickly understand what's going wrong. I also correlate that inside of Galileo. So Luna really unlocks this real-time evaluation aspect, even if your models are in production, to understand, to get to know which parts are good, which parts are bad. So, if there's one big takeaway from all of this, it's that LLM evaluation research is very critical, but it's also very underserved. When we started working on this entire path many years ago, we already recognized that most of the research work that was happening were was uh, was happening on the model building side, right? Like how can we build bigger, better models? We've all seen this story before with BERT as well. BERT came out, and then there was Distilled BERT, and there was some other models, and they were all trying to be bigger and better, but folks weren't talking about the big gorilla in the room, which was sure, but how do you evaluate the quality of the data? How do you evaluate the quality of the labels? And it's the same thing all over again, where now you have a Gemini model, great, very, very large model, amazing, but still, how do you evaluate them? How do you evaluate the inputs and the outputs? So it's very, very important to keep pushing the envelope on this. And so we keep thinking of our job internally at Galileo as, there's lots and lots to do here. So what's next for us? We have many, many ideas for further optimizations for Luna accuracy. 80%, we can increase this even more. It's already best in industry, but we can increase this even further. We're planning to also work on Luna for closed book evaluation tasks. What does Luna mean for agentic evaluation? There's a lot in the works there, as well as multimodal evaluation, as we're increasingly starting to move towards really exciting use cases with with image to text, audio to text, etc. So what does it mean to have an evaluation model on that side? Um, and there's a lot more that we plan to do going forward in order to make this happen. So this is this was a whirlwind explanation of what Galileo Luna is all about and all of our research so far and some of the next steps. And I'm sure we'll come back again in 3 to 5 months and have more of our research for us to share with the community. Uh, but I know there's been a lot of chatter and questions, and hopefully we've been resolving most of them already. And what we'll also do beyond this webinar is we'll follow up, number one, with all these slides, with links to the papers, with more information about your questions. Definitely don't want your questions to be unanswered. They're all, I'm sure, super valid questions. So we would love to answer each one of them and get back to you with that. I don't think I'm trying to take a stab in the next 4 minutes is going to do you justice. So we'll definitely get back to you with good answers. But hopefully, if anything, this leaves us with the understanding that LLM evaluation R&D is super, super critical if we actually want GenAI to be a thing that is being used in production. So thank you so much, everybody, for being a part of this. Really appreciate you spending the last hour with me, and I'm honored to be presenting some of the work that Galileo has done. But if you have any thoughts and questions, please reach out. I feel like also we're growing our team quite a lot, so would love to hear from you on that front as well. Thank you so much for everybody to be dialing in from all parts of the world. Hopefully this was interesting. Hopefully this was very exciting and stimulating. And until next time, thank you so much.